Hello guys, welcome to today's LeetCode problem. The problem says that maximum number of points from the grid queries. So what is the given problem is that we are given the m cross n integer matrix grid and the array queries of size k. Find an array answer of size k which is equal to the length of queries. Okay, for each query I, you start from the top left cell of the matrix and repeat the following process. What is the process? If queries of I is strictly greater than the value of current cell that you are in, then you get 1 point, that is +1. If it is a first time visiting, okay, for that query of I, and you move to the any adjacent cell in all 4 directions, that is up, down, left, right. Otherwise you do not get any point and you end this process if the cell value is not strictly less than query of I, because they have said query of I should be strictly greater than. Okay, so what is the problem is saying that after all process we have to return, okay, after the process answer of I should be the maximum number of point you can get, correct? So what is the problem is saying that we have given this matrix 1 2 3 2 5 7 3 5 1. So this is something that is here. Query of I is given 5. I started from this point, correct? I started from this point. Now I want to reach all possible neighbors from this 0 0 top left basically, where cell value should be less than the 5 only. So I can go from here to here. I can see from here I can go here, but I have already visited this, so I will not go in this direction, but I can go in this direction. So 2 direction I have. But you can see as the value is not strictly less than the current value, it's not strictly, I would say, less than, then I can't take this, but I can take this one. From here I can go here as well. From here I can go here and here. But as this is not less than, I will not go here, but I will go here. From here I can go here, here. I can go here. But these are not valid direction, out of the bound. I will not go there. As I have already reached or visited this, I can't go back again to the same cell. So I can go here. So you can see I am able to go at 1 2 3 4 5 places. That's why the output for this query of I, that is queries of 0, is 5. Similarly for this 6, okay, similarly for this 6, if you see in this test case, I can go here, 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 here. Total 8 places. That's output is a 8. For this 2, similarly I can go only from here to here. In a case, if this would have been 10, in any case this would have been 10, so output for this all 3 queries would be 0 only, because the first element, the starting point, is already the 10, which is greater than all of these. So all of these output would be the 0 only. Now how to solve this problem? So if you see, correct, we have given this matrix. What we are doing, we can do a simple way would be just do the BFS or DFS, correct? Take a query of I, correct, and just do the BFS on grid, simple, and count elements which are less than the query of I. Simple, right? So this is simple BFS only. If I start from here, I just have to do BFS and I just have to count the all neighbors which are less than the query of I. That would be the simple. But let's try to see the constants given there. So right, for BFS the time complexity in worst case would be the big of row into columns for the grid, and for each query we are doing this, so it will be the queries, so it will be into queries, length of queries, correct? In worst scenario I am talking. But what are the constants given here? If you see, so constant given that k means queries length is 1e4, that is 10 raised to 4, and m cross n is given 10 raised to 5, which is ultimately 10 raised to 9, which is wrong. We have to bring this anyhow around 10 raised to 6 only. So because this is not acceptable, this is not going to be the big of n solution, correct, which can be accepted by the compiler. So we have to bring it somehow to the 10 raised to 6. How we can do this? See, approach would be simple, approach would be same. We have to use the BFS here to count the number of cells that are less than this queries of I. But we need to have some observation here. What is my observation? These are my queries, right? So just tell me one thing just tell me, the cells which are less than 2 will be 100% less than 5, and the cells which are less than 5 100% will be less than 6, correct? So just tell me, if this is my matrix, okay, this is my matrix, with the help of 2 I am able to reach here, I am able to reach here, I am able to reach here. So when I am doing the BFS for 5, do I need to go again into these cells, this, do I need? Not really, right? Because if something which is already smaller than 5, which is the 2, which is able to reach here and which is not able to reach here, here, then when I have the 5, my goal would be to check whether it is possible to go here, here with the help of 5, correct? So the goal is like, okay, start from the, okay, sort these queries. So after sorting, the queries would look like this right now: 2, 5, 6. Start using this 2. So using this 2, if this was my given original matrix, that is 1, just let me draw here, 1, 2, 3, 2, 5, 7, 3, 5, 1. So now my query element is 2, correct? Using this, I will just keep here the count for the query 2, how many cells I can visit using the 2, correct? So for this 2, initially I will start from here, correct? And into my queue, if I am using the BFS, for example, BFS, I will just keep a queue. Initially I would have the 0, 0, correct? And as I want the cells less than equal to the query element, so I will try to keep the mean heap here, mean heap, in which I will put the grid value as well. So what I will do, I will just put here the grid value, that is 1 grid value, and the row and column. This is something that I will try to put. So initially I will have 1, 0, 0 in my mean heap, correct? So now I will say I am here, my query element is 2. So what I will do, I will check, is this less than? Yeah, it is less than. So I will just increment my count by 1. I will remove this and I will try to put now my neighbors. So what is my neighbor now? This is my neighbor. So it will be 2, 0, 1, because row is 0, correct? 0, 1, 2, 0, 1, 2. So 0, 1, correct? And I will try to put this, which is again 2, 1, 0. As this is the mean heap, so this will come first because it will give priority to the second element, that is row. Make sense? Now I would say, I will just take a top of the my queue. I would say now this element is not less than query. So I will stop here my iteration. Make sense? If it is done, now I will try to take the 5 out of this. Now my query element is not a 5, is not a 2, it is a 5, correct? And for query 2, my answer was 1, correct? I will keep count 1 as it is for 5 as well. Now I am now for the 5, I will say, is this less than? Yeah, it is less than. So what I will do, I will just increment by count by 1, it will become 2. I will take it out, so it will be removed, and I will try to put neighbors. So for 0, 1, neighbors is this, neighbors is this. So as it is a mean heap, so again 2, 1, 0 will come up, then 3, as the value is 3, then 0, then 2, then this 5 will come up, that will be the 5, 1, 1. Make sense? Again I will take this out, top element, which is again small, so I will just increment my count by 1, that will become 3. And now, my bad, now you can see here, for this neighbors 1, 0, 1, 0 is here, right? 1, 0, neighbor would be this, but this is already visited, so I will keep a track of visited array over here as well, or visited set, you can say. I have already visited, it is already in queue, so I will not go there, but I will try to go here. So I will put it again, so it will become now 3, 0, 2, as it is a mean, this will come first, then 3, then this will come first, 2, 1, then 5, 1, 1. Make sense? Now again I will take a top, which is again smaller than my query element, that is 5. So I will increment the count by 1, that is 4 now, and I will take it out. And for this neighbors 0, 2, right? So for this one, for this neighbors are this, which is already visited, so I will try to put this one now. As it is a 7, so it will go last, that is 7, 1, 2. I have already 5, 1, 1 here, priority it. I have the 3, 2, 1. Make sense? Now I will again take the top outside of the queue, so which is again smaller than my query element, so I will increment my queue count by 1. So now I have taken it out, 3, 2, 1. So row is 2, this is 1. So I have already visited, I will not go here. This is out of bound, I will not go here. This is out of bound, I will not go here. I will go here. So I will try to put 5 2 1. So initially 5 1 1 will come first, as it is a min heap. Then 5 2 1 will come. Then 7 1 2 will come. I hope that is making sense. Now I will take this out, but this time the 5 and this 5 are equal, not less than. So I will stop my iteration, and I will just say for this 5 query element 5, my count has become 5. Makes sense? And now I will take the next element in my query, that is a 6. Now for 6, for query element equal to 6, correct, I will take this out, as it is less than of this 6. So I will just take it out, and I will just increment by count by 1, that is will become 6 now. So for 5 1 1, I will just take the neighbors now. 5 1 1 is here. Neighbors are this is visited, this is visited, this is something visited, this is something visited. So I will not put anything, I will just remove it from my queue. Now I will take the next one, which is again smaller than 6. So I will just increment the count by 1. So 6 would become now 7, and I will just take it out. So 5 2 1. For this 2 1 that is here, which are the neighbors? This visited, I will try to put this one. That is a 1 2 2. So as it is a smaller, so I will just put it 1 2 2, 7 1 2. Correct? Now I will just take the top element of the queue outside, which is smaller than 6 1 to 2. So I will just increment 7 by 1, that will become 8 now. I have just taken outside. For 2 2, I will just take the neighbors. For this 2 2, neighbors is this one, which is visited, this one visited, out of bound. So done. I will just take this outside. 7 1 2. Again, this 7 is not a smaller than 6, so I will just remove it, and ultimately you can see my queue has become now empty. I am done. So if I am done, I will just say 6 for 6, output is 8. So if you see, for 2 the output was 1, for 5 output was 5, for 6 output was 8. And if you see, same thing, right? For 5 the output was 5, 6 output is 8, for 2 output is 1. So this is what we have to do. So if you see, I have traversal the BFS only one time now. I haven't done the traversal for query of I into BFS. So for each query I have to do BFS. No, it is not a case. I am doing only one time now BFS. So I am neglecting the things we have already visited for small queries of I. So that is a catch over here. So if you analyze the time complexity, what we are doing? We are doing BFS only one time. So that is big of n cos m. Correct? Only one time. Plus we are sorting the queries of I. So it will be big of k log k. Correct? And as we are using the min heap, so taking this minimum element outside or inserting the minimum element into the min heap would take big of log of m cross n. Correct? So ultimately the time complexity would be big of log of mn into big of n cross m plus big of this should be big of k log k. This is something log of m cross n. We can neglect this part, which will be lower, because this is log of 10 raised to 5. This is 10 raised to 5 plus 10 raised to 4, which is ultimately will become somewhere around 10 raised to 5 log 10 raised to 5. Correct? So this is how you can solve this problem within a time constraint. Code for this problem is simpler. What I have done, I will just try to go through the code. Okay, what I have done, I have just taken the length of the grid here. I have taken the queries with index. I have just, because I want to return answer in a indexes order only, so that's why I'm maintaining the index over here, because whenever I'm saving the answer, I will save it based on the index only. Correct? This is something I'm doing here. This is my result, who will be the containing the count for each query of I. I am using the min heap over here, heap, where first element is the grid value, row, column. Visited is array, not to visit, again same thing. Initially I will visit the first top left, that is 0 0. Total count will tell me at every step how many cells I have visited so far. What I'm doing for query and index, in this queries with sorted, I'm just doing the BFS with the grid. I'm passing the grid, I'm passing my current query, I'm passing my min heap, I'm passing my visited, and I'm just incrementing my total count by the new count I have got. It means how many cells I have visited using this query. Basically this is what the BFS is telling, and I am just putting that into that index, particular index. I am returning it. Now let's see the BFS. It is a simple standard BFS only. I have 4 directions, so I have taken the directions array. Count will tell me how many cells I have visited. I am running this loop, while loop, until my heap is there, it is not empty, and my heap first value, that is 0 0, it means nothing but this one only, grid value, until it is less than my query. Then what you have to do, take up the top element of the queue. Top element, whenever I am saying top elements means left side element, okay, it is a mean heap only. Increment the count and try to reach out all the neighbors. Okay, first of all check whether it is valid row, valid column, and they have not been visited. Okay, new row, new column have not been visited. Then then mark them as visited, then push it into the queue, and that's it, and return the count at last. So this is what I'm doing here. I hope you got this problem. See you in the next video. Thank you.